Who the man? Who the man? Who the man? Who the man?
Plus sign, multiply, subtract, and divide. Get math in your mind, then you'll see your dollars rise.
Teachers have your kids play video games, cause it helps to get the math facts into the brain. Simple and plain, we educate with minimal strain. Have fun, everybody now, isn't it great? Try some long division today, we just give it away. No time limits, you can...
Alright, video 41.
41.
I know. Interpreting a computer readout. So these are more real world, what you guys would be seeing if you're real statisticians.
Is this about the last video?
Wait a minute, of the year?
Yeah.
I don't think so.
All right. Are we halfway done? All right. I'll stop asking questions. It's better just to keep going.
I'm gonna bet we're like a third, but
We're doing it though.
we'll see.
All right.
Okay, so basically, computer readout is gonna look. My pen over here. Something like this. All right. You'll have a bunch more numbers actually when you do it, but this is kind of what it's gonna look. Depending on whatever software you use, it'll look slightly different, but you'll always have these main things coming out.
Yeah, I think this was
Okay.
a software called Minitab. I don't know
Yeah.
how big that is in the business world now, but it was very popular a while ago. And the AP test loves this. Okay, so this appears over and over again as I look through free response questions. All right.
Okay, so first thing first, you're always going to figure out from either this large description or sometimes they'll just give it to you on the readout, what's your explanatory variable and what is your response variable.
Could you put an X
Okay.
above the explanatory variable?
I
Just as a
can.
little reminder, that's the X variable. The response is the Y variable.
Yes. Okay, so in this one, scatter plot with body body fat, okay, let's see if I can talk, on the y-axis and the waist size in inches on the horizontal axis. So our explanatory, this was the waist size, and then this was the body fat.
So we're using waist size to predict body fat.
Yes.
Okay. Now, equation for the line of best fit.
Okay.
So there's no data to enter.
No.
Someone already did that in the computer program. It's about reading the output. Like our calculator gives us A, B, R, and R squared. And the computer gives us more information, but there's only two numbers we really care about.
Correct.
Which one is the y-intercept and which one is the slope?
Right. And both will be found right here under the coefficient section. The dean and a student, always fun.
If Tommy Jones is watching this video, I hope he went to the office.
Something tells me Tommy Jones would never be caught dead watching this video.
You know him?
No, but
I do.
All right.
And you're right.
So the
Sorry,
constant,
Tommy.
this is the y-intercept, okay? Getting back to what we are. So this is the b of the equation. And then the m's,
No, it's not.
oh,
That's the A.
a, I'm
Because
sorry.
we're doing y
Yes.
equals A plus BX.
My bad.
That's
Yes.
right. So
We're
the constant-
reflipping it.
Yeah, so
my fault.
That's right. The constant is the y-intercept.
Okay. So here it'd be negative 42.734.
And it's the term without a variable, which is why it's called a constant.
Right. And so the coefficient then for the waist size, so our x variable is 1.7. So then you do plus 1.70x.
Okay.
And there's
And one thing we talked a little bit about is, just so you know, on the AP test, you may have to define the variables. So if you write an equation with y and x, you have to explain what y and x are.
yes.
Or just use the words, you know. So you could say that body fat hat equals negative 42.734 plus 1.70 times waist.
Yes. Always
Okay,
would work
so-
as well.
Just so you're aware of that. All right, that looks beautiful. So we just had to read it off. So you got to remember the x variable is listed there, waist, and the number that multiplies it is the slope.
All right. Okay, then the last one we want, what is r squared? So then that also can tell us what r is. So we'll go into what r squared is coming up later this week. Okay, but they do give us, they're going to give you the r squared. Sometimes if your software is nice, it'll give you r, but most of the time it'll be r squared and adjusted r squared, which again, mean nothing to you at the moment, but we'll get there
Maybe,
as the week
I don't
goes.
know if Mr. Lewis knows, but correlation is always a smaller r, a lowercase r. And this thing,
Yes.
r squared, they always use a capital R. I don't know why.
Yeah, I don't really know either.
But
It's kind of like what they
Could you
do.
write capital R squared? equals, and then we want to write this as a decimal, 0.678. So r squared is 67.8. That actually has a meaning. But right now, we're just trying to get, how do we get r from this readout?
Mm-hmm.
So we can take a square root,
Yep.
but there are two possibilities. It could be plus the square root of 0.678, or it could be the minus square root of 0.678.
Yes.
All right, could you put plus or minus?
Plus.
Let's
or
keep both right now.
minus.
The square root of,
So what's the square root of 0.678?
could you, maybe you could write that for us, and then we can see it visually, and I'll let you know what that is.
He just wants me to waste time.
It is plus or minus 0.823. So if we're given r squared, we can take a square root. So you remember there are two numbers, when you square them, give you 0.678.
Yes.
Now, how do you decide whether it's positive or negative?
Well, we can look at the slope.
Very good. If slope is positive, the pattern is going up.
Yes.
And r should be positive. If the slope is negative, it's going down, and r should be negative. So
we're going to use the positive 0.823.
good. So you have to pay attention to which direction the pattern is going.
Yes, you
to
do.
understand that. You get the right value of r. Okay, it looks like it was a pretty strong pattern.
All right. So let's look at a different example.
All right.
All right.
We'll roll
Here's-
through this one.
Here's another mini tab one. Again, this time no problem to explain what this is. We just have to look at what the explanatory and the response is.
Okay.
And right up here, they give us our variables. Volume versus the height. So Mr. Miller, which one's the explanatory and which one would be the response?
The x variable, which is explanatory, should be the height, and then also that's the one they list down here in the variables.
Yes.
So height.
Height.
And volume will go on the y-axis. That one's the volume. So we're using the height to predict the volume of the tree, I guess.
Yes.
Right. Okay. Write the line of best fit. Let's practice using the variable names. So we can say volume hat.
Okay. Volume. Hat
Right? And the hat means it's our approximation. Equals.
equals.
The constant is the slope. So negative 87.12.
Plus 1.54. Put 3. Okay. Here's our x coefficient times the height.
All this other stuff, don't worry about right now. I'm not sure we'll ever worry about some of that other stuff.
Right. So then what this would mean would be for every 1 our height increases, it goes up by 1.54 for the volume.
That's true. That's rate of change. Very good. On average.
Yes. On
You
average.
gotta say on average, or it'll take
Correct.
off. Okay, what is r squared? So where is it here? Did they give it? Oh yeah, it's
They
right
did.
there. RSQ.
Right
So
here. Not as big.
r squared is
So not as big of a correlation on this one. 35%. So 0.358.
and are we gonna want the positive or negative square root?
We're going to want the positive because we have a positive slope.
Okay, so the pattern's going up. R should be positive.
So
We
R
get 0.598.
598. So fairly strong correlation. It's moderate.
Okay, moderate. I'll say
You know,
moderate.
moderately strong. You can throw
I mean,
in all
it's there.
you can throw in all these adverbs and adjectives in there.
Yeah, it's like Starbucks. You know, slightly, slightly moderate. I don't know. Fairly strong. That's a hard one, but I think moderate.
Yeah.
Okay.
Okay.
Now,
Ooh, big AP.
okay, we'll try to go through this quickly. This one's not
Okay.
that problem, but here's an example that uses a computer printout.
Yes, this would be what you would see on your test. So we have this big long line. Basically what's happening here is we looked at 12 aircraft to look at how much the operating cost per hour changed based on how many passenger seats the plane had.
So it looks like it's, well, the overall pattern, the line they're drawn is positive. So
Yes.
the more passenger seats, the more cost, probably the bigger plane.
Right.
Okay.
Okay, so using this, they ran the regression and gave us this nice little readout.
Cool. Circle
Okay.
the part we really care about.
That would be right here, actually, right this column.
Okay.
The R squared is not always in that column, but that's what we care about.
So they didn't ask the explanatory or response, but the explanatory variable, the x variable, is seats, and the y variable is cost.
Right. So here, we'll do the number thing because they asked us to write the equation. So cost hat equals
11.36.
1,136
Oh, thank you.
plus 14.673 times the number of seats.
So on average, for every additional seat, it costs $14.67 more dollars.
Yes,
Okay.
would be what that is telling us. All right, and that's exactly what you guys would describe when you're doing that. Okay, so you'd want to define the variables used here and here. You know,
Okay.
the more you're writing about it, the better.
See where it says define the variables used. So that's telling you, if you use x and y, you would have to say, after you write the equation, x equals the number of seats, y equals the cost.
Right.
Okay, you might as well just do this. All right, what is the value of the correlation coefficient for operating cost and the number of passenger seats on the plane? So r squared is 0.57.
Yes.
And Mr. Lewis, is this positive or negative?
0.57. Well, based on the chart they gave us, it's positive. Also, based on our slope being positive, it would be positive.
So we're sure?
Yes.
Okay.
Pretty confident.
All right, so we'll take the positive square root. It would be 0.75.
0.75.
Okay. And interpret. That's a pretty strong pattern. It's not really, really strong, but 0.75, fairly strong. I don't know. If you go back a slide,
We're going to lose our work, but that's okay.
if you go back a slide, actually, ours is 0.7, but it's not a really strong pattern.
No. And that's kind of what part C kind of is talking about.
Yeah, okay.
So let's look at part C now.
All right, here's the cool question. This is the total AP twist.
All right. Suppose that we want to describe the relationship between the operating cost per hour and the number of passenger seats on the plane for planes only in the range 250 to 350. So we're taking these guys out.
Yeah,
top.
and actually those lower guys too.
Yes, and this guy, I'm sorry, or these two guys. So this group right here.
Yeah.
All right.
So imagine we only had that data set.
All right, so does the line shown in the scatter plot still provide the best description? I'm thinking no.
I'm thinking that if you're just looking at those points,
Yeah,
that line's going totally the wrong way.
Yeah, this looks like we want something that looks like this.
So if you remove those points, totally changes the direction of the pattern.
Yes.
Okay.
And then we would just describe why that would be.
Yeah, so pretty much all you'd have to say is now there's a negative association between the points.
Mm-hmm.
The slope of the line of best fit should be negative now. And so it'd be completely different.
Which is kind of interesting that would do that. But in this situation, it would. Okay. So I think it's time for you guys to do it. It is. It's journal time.
Well, it always is.
All right. So we gave you another nice little mini tab thing. So this would be just like problem 2. Okay, so if you want to look back, just so you can kind of see that the computer printout's the same. So we're looking for the equation for the line of best fit, r squared and r, and then what is the coefficient for essays and what does this represent? So I want to know what this number right here represents.
So you know the coefficient for S. Oh, okay. So the variables are a little weird if you look. The y variable is maths, and the x variable is essays.
Yes.
I'm not sure what maths are, but
Not really.
they get a score on their math tests and essays. So it's analysis of scores. Okay. So I guess they're comparing their math scores and their essay scores.
I don't know. Maybe they're just adding S to things.
Okay.
I think we should just make everything in the world plural.
Their chemistries. Anyway, we'll stop here. I think it's a good place to stop, Mr. Lewis.
Yes, and we will continue with this tomorrow.